Hello, my name is Elmer, and this is my video for test 2. The question is, which is the stronger acid? So we have H2SO3 and H2SO4. So the first step in this is to draw the Lewis structures of both compounds. So let's start out with H2SO3. So S is going to be the central atom for this one. So S, then we have 3 O's and 1 H, or 2 H's, each one attached to the O's. So we know the Lewis dot structure is going to look something like this. There's going to be one double bond, and the other O's are going to have a single bond. Then we draw the valence electrons, and then all of them total to 26. So we have 26 right here. Then we also draw the Lewis dot structure for H2SO4. So we'll draw it over here to the right. So S is going to be the central atom. Then we have 4 O's attached to it. So we'll have O's and the same amount of H's. So we'll put the H's down here and to the right. And also we're going to have the same amount of Lewis dot structures. Oh, messed up here. Lewis dots, or valence electrons, my fault. Valence electrons. So we're gonna have 1, 2, 3, 4, 2, 4, 6, 8, then 2, 4, then 6, 8. Then we know these two up here are gonna be double bonds with the S. And the valence electrons are gonna be 1, 2, 3, 4, and 1, 2, 3, 4. Now, after drawing the Lewis dot structures, we take the conjugate base of it. So we know, let's take the OH on this one. It's going to be on this one, this side. And we also take the OH on this side over here. So, and now we redraw the Lewis dot structure of it. So this one's going to be the conjugate base, HSO3 minus, which is equal to S as the central atom. And then we're going to have our O over here, which is O, 1, 2, 3, 4, 5, 6, minus. Then we're going to have our O down here, and our H attached to here. And we also have another O over here, but this one is going to be with the double bond, which is 1, 2, 3, 4. Okay, then we also want to draw the conjugate base for H2SO4, which is going to be HSO4 minus. And the conjugate base structure is going to look something like this. So we have the S as a central atom, a double bond, O up here, so 2, 1, 2, 3, 4, and a double bond to the left, O, 1, 2, 3, 4, with the conjugate base over here. So we have the O attached to the S, which is 1, 2, 3, 4, 5, 6, the minus. Then we have another O down here, and our H right here. So first, on our comparison, they look the same, but let's start out first with size. So size, in this case, it's going to be a O versus O, which they're both the same, so we can't base this off the size, so this one's a no-go. So then we do electronegativity. Again, it's going to be O versus O once again, or OS versus OS, since these are the two attaching atoms right here, OS, then OS minus. And again, it's the same thing, so we can't base it off of this one, so this one's a no-go. Then we go down to resonance. So we're going to do R. That's a B, my fault. So R. So let's look at the resonance structure for this one. Essentially, to save more time, or a quicker method to do this is look at how many O's are attached to it. Since both of them share the same central atom, you can do this. Only works for when the compound have the same central atoms. So we know So that's the first requirement. So it meets the first requirement. So both of them share the same central atom, which is S, this one and this one. Now by looking at this, okay, then the second that's just basically the first requirement. So now we could tell which one has the more resonance structures. This is the one that has more O's attached to it. So the first one has 3 O's, which is O3, and the other one has 4 O's. And the one with the more O's is the one that has more resonance, and that's what we want. So the one with more resonance is, so let's write it here, HSO3 minus versus HSO4 minus is the one with the more O's. So we see it here, there's 4 O's. So here, so basically the one that has more resonance is more stable. And more stable, that means it's a stronger acid. So this one is a stronger acid. So here, this is more stronger than that. So we know this one is the stronger acid. Okay, thank you very much for watching the video, and